What up, what up? And thank you all for visiting. I am your teacher and facilitator, D Math Professor. And guys, you already know what it is. If you see it, please go ahead and hit me with a like or a subscribe. Tell everyone that you know that we have a great time talking about algebra and making math simple. Well, I already hit you with the intro. You already know what this lesson is going to be about. Word problems. There are problems with words. See how I did that? Word problems, problems with words. Whatever. Anywho, the point I'm trying to make is, I know a lot of kids struggle with the concept of algebraic thinking and word problems because granted, there are a lot of different variables that can contribute to why you just don't like word problems. But I think at the end of the day, it comes down to a special word. And you know what? Let's go ahead and kill two birds with one stone. We'll make this word the word of the day. And that word is going to be phobia. Say it with me. Phobia. One more time. Phobia. And I think a lot of people have a phobia when it comes to word problems. Like there's already this level of apprehension. Well, I could have made that the word of the day too. Boy, I'm on a roll. Okay, we'll toss that in for the next video. Anyways, there's this level of apprehension, and that just means that you approach a word problem already with the mindset of this is hard or I'm gonna get this wrong, okay? And so you don't have to admit it. I've been working with people for such a long time that I know this to be true. So what I'm gonna do is I'm gonna provide some tips and strategies, because just like with walking across the street, if you know how to walk across the street, then the odds of you getting hit by a car when walking across the street are very slim, or the probability is very low. However, if you've never been taught the different types of strategies or methods to cross the street correctly, then obviously every time you come across a crossroad or a road or street or whatever the case may have you, there's going to be a high level of concern because you don't know if you're going to make it to the other side, if that makes sense. So today's lesson is going to give you the strategies that you need to make it to the other side. And so since we've kind of already been working on the function rule, input, output, slope, intercept, form, and just different things having to deal with both slope and y-intercept, I decided to take a couple of word problems, and we're going to work this thing from a level of easy, novice or intermediate, to something that's a bit more complex, so that you can see that the strategy works irregardless of the word problem. So this is a strategy that I kind of pinned together as I, from when I was a kid all the way up into college, and now as an educator, I found that this strategy has always helped me through some of the most difficult word problems. And so hopefully it helps you out. So enough yip yap, let's get to it. So we're gonna start off with the slope-intercept equation. The first thing I wanna do is identify the various parts of this equation. So real quickly, y represents our output, and then we have our value for m, which is represented as our slope. X is gonna be represented as our input value. Very important that you lock these things in. And last, but certainly not least, B is going to represent our y-intercept. The strategy that we're going to use requires that you have a good understanding of what is being represented in the equation. The one that we're really going to dig into, though, is being able to identify X within a word problem. So like there are ways to identify the output. There are ways to identify the input. There are even ways to identify the y-intercept. But I found it over the years that it's real easy if we can spot our X variable within the word problem, then whatever number is tied to that is our slope. So if you find X, you automatically find slope. So when reading word problems, it's best to find keywords that tie to the variable X. And that's the strategy, is to find keywords that tie to our input value. Okay, and so let's talk about what those keywords may be. Now I've identified about 5 keywords. Now, please understand this is not absolute. There are going to be questions that may not include any of these keywords. I found that most of the questions that you're going to come across is going to include one of those 5 keywords. That being said, let's jump into a word problem and see how to use this strategy. All right, so here's our first one. And it reads, for babysitting, Nicole charges a flat fee of $3 plus $5 per hour. Write an equation for the cost C after 8 hours of babysitting. What do you think the slope and the y-intercept represent? How much money will she make if she babysits for 5 hours? All right, so the first thing I'm going to do is I'm going to underline the terms that contain numbers. And then I'm going to try to identify what keyword is being used based off of what I provided to you earlier. And based off of that list, I see that the word per is being used. So per in this example is going to represent my input or my X. So at this point, I know that whatever number is next to the word per is going to represent my slope. And in this case, it looks like the number 5 is directly next to the word per. So that number 5 is our slope. So let's go ahead and set up this equation so that you all can see this thing in action. So I'm going to go ahead and write my y, which is my output, equals 5x, because 5 is my slope, x is my input, plus the y-intercept in this case is going to be the other value of 3. We know it's the y-intercept, we know that it's positive because this is money that she's making when she charges her customers. If she was losing this money, clearly it would be negative. So pay attention to those keywords that you all learned way back in elementary about what keywords were for positive and what keywords are tied to negative values. Okay, now they want to know how much will she make if she babysits for 5 hours. Now, the thing I want you to lock in as well with X is that X will typically represent time in a word problem. Not always, but most of the time it will represent some form of time. And so, things like minutes, seconds, hours, days, weeks, years, those are things that are typically tied to our independent value or X. So keep that in mind. So in this case, X is going to be replaced with the number 5, and I'm going to plug that in. And so I now got y equals 5 times 5 plus 3. And we're going to do our basic math here. We know that 5 times 5 is going to give me 25. And when I combine that with the 3, that's going to give me 28. So the total amount that she's going to make after 5 hours is $28. Now, real quickly, we're going to take a quick pause for the cause because I mentioned the word phobia, but I didn't get a chance to define it. So I think it's important that we talk about our phobias because in talking about them, we can probably find a resolution or find that some of these phobias are a bit illogical. Okay, so I'll go first. So, and this is kind of tough for me, guys, so bear with me. When I was a kid, I saw the movie Boys in the Hood. The movie was played by the cast of Ice Cube, Cuba Gooding Jr., and Morris Chestnut. Well, there was a particular scene in the movie where Morris Chestnut's character, his name is Ricky. And Ricky is walking, him and his friend is walking from a corner store. Ricky is playing or scratching off a lotto ticket. A car pulls up that's been looking for him in retaliation to something that his brother did. And in the process, he doesn't see the car. And his friend, who's played by Cuba Gooding Jr., yells, "Ricky," right? And so that scene has been embedded in my mind like all my life. So at this point in my life, like whenever I hear somebody yell out the name Ricky, I run. So here I am, trying to hit those 10,000 steps, so I figured I'd take a walk around the neighborhood. Little did I know that this day would forever change my life. On my phone, texting some friends, again, getting those steps in, I noticed one of my neighbors come out the house. Cool guy, I see him from time to time. And for whatever reason, he yells, "Hey, Ricky, get in here and wash these dishes." But that ain't what I heard. I heard, "Ricky!" Needless to say, my neighbor actually never looked at me the same way after that day. All because of a stupid phobia. So, as you can see, that phobia might be a bit outlandish, but the way that I was able to get over that phobia is to realize one important thing. My name isn't Ricky. So the next time somebody yells out Ricky, I'm gonna just mind my own business. Okay, in this example, it says Tim buys a new computer for his office for $1,200. For tax purposes, he declares a linear depreciation loss of value of $200 per year. Let Y be the declared value of the computer after X years. What is the slope of the line that models this depreciation? Find the y-intercept of the line. Write a linear equation in slope-intercept form to model the value of the computer over time, and then find the value of the computer after 4.5 years or 4.5 years. My focus is going to be one, to create the equation that belongs to this to the word problem, and then to be able to answer the question about the value of the computer over 4.5 years. So wherever we see the word per, That's our x, and whatever's next to that word is our slope. And in this case, it looks like the number 200 is directly next to the word per, so 200 is going to represent our slope. We have y equals 200x. Now, I want you to keep in mind that in the word problem, it did say that this 200 is a depreciated value, or you're losing value. And whenever I see the word loss, and I hope you do too, you should know that we're subtracting or something is negative. So this slope is negative. So be careful with those keywords. All right, great. Now I'm going to take the other value as my slope intercept, and that's going to be 1200. We know that this is positive because that was what the value of the computer was when he initially bought it. Okay, cool. All right, so now we have our equation, y equals negative 200x plus 1200. Now they want us to find the value of the computer after 4.5 years. Remember, whenever we got to plug something in, x will typically represent time. So in this case, years is going to have to be x because x typically represents time. So I'm going to rewrite this equation, and wherever I see an x, I'm going to replace it with 4.5. And so this is the new equation. Now let's do some math and figure out 4.5 times 200 is 900, guys. Let's keep that simple. So that's a negative 900 plus 12. For those of us that may have forgotten, whenever you have an equation, pay attention to the sign values. This guy is negative, this guy is positive. Whenever these signs are different, I automatically take the difference or subtract, okay? And difference simply means big number minus little number. That's the easiest way for me to break that down, if you're taking the difference between two numbers. So I'm really looking at 1200 minus 900. 1200 minus 900 is going to leave us with a difference of 300. And so now I'm going to rewrite this question where y is going to now have a value of 300. So after 4.5 years, this computer is only going to be worth $300. When you're approaching these word problems, just remember that they're solvable, okay? No one is going to come up with a word problem that can't be solved. The question is, will it take you a minute to solve it? Will it take you 5 minutes to solve it? Or will it take you 10 minutes to solve it? It doesn't matter how long. It's just you got to approach it like this thing is solvable. This whole idea that we're going to approach a word problem and it's impossible to solve, get that out of your mind and get that whole phobia out of your system, and you'll find approaching word problems to be a very pleasant process if you approach it with the tips and the strategies.